Number 4, consider the following statement. If today is New Year's Eve, then tomorrow is January. I'm considering it, and I think it's true, right? If today is New Year's Eve, that's December 31st, then tomorrow must be January. Yeah, true. So I'm just going to put that there for my own benefit for later. I want to write each of the following statements and decide if it is true or false. So it will help me to use some symbols. So today is New Year's Eve, we'll call that P. And tomorrow is January, we'll call that Q. So what my original statement is P implies Q. If P, then Q. So P implies Q, which we think is true. The negation of P implies Q, not P implies Q. Remember, the negation of an implication is, just like when we talked about the truth tables, the only way this can be false is if P is true and Q is false. So P and not Q. So those two are logically equivalent. So when I write it down in words, I would say today is New Year's Eve. And tomorrow is not January. And that's impossible, right? It can't be New Year's Eve today and tomorrow not be January. So that is false. Okay, the contrapositive of the original statement. So the contrapositive of P implies Q is not Q implies not P. So in words, that says, if tomorrow is not January, then today is not New Year's Eve. And that is true. If tomorrow is not January, then it's impossible that today is New Year's Eve. So true. And you'll also recall that an implication and its contrapositive are logically equivalent, so they'll always have the same truth value. Okay, the converse of an implication, P implies Q, is Q implies P. So Q is tomorrow is January. So it says if tomorrow is January, then today is New Year's Eve. Okay, true or false? So if tomorrow is January, then today is New Year's Eve. This is not necessarily true, right? Because today could be January 3rd, right? So tomorrow is January, but today is not New Year's Eve. The if part is true, but the then part is false. So this is false. And the converse and the original statement are not logically equivalent. They do not always have the same truth value. So sometimes they do, but they're not logically equivalent, so that they don't always have the same truth value. All right, and then the inverse of a statement, P implies Q, is not P implies not Q, which happens to be the converse of the contrapositive, right? But the inverse of P implies Q, you just put a not on both parts. Not P implies not Q. All right, so that says if today is not New Year's Eve, then tomorrow is not January. And that is not true, right? If today is not New Year's Eve, it could be January 3rd, and tomorrow is in fact January, right? So this statement is false. And because it's the contrapositive of the converse, right? Because it's the contrapositive of the converse, contrapositives are logically equivalent, so they have the same truth value. They always have the same truth value. Number 5, write each of the following statements in if-then form. Catching the 8:05 bus is a sufficient condition for my being on time for work. So I know that if I catch the 8:05 bus, I will be on time, right? That means that's what sufficient means. If I catch the 8:05 bus, I will be on time. Now, they didn't say it's a necessary condition, which means maybe there's some other way I can get to work on time. Like you could also catch a ride with a neighbor or catch the 7:30 bus, right? So if I catch the 8:05 bus, I will be on time, but it's not a necessary condition. Like it's not the only way you can be on time for work. Now, my next statement has necessary. So doing homework regularly is a necessary condition for Jim to pass the course. That means he has to do his homework or he won't pass, right? So if I want to write it as an if-then, I would say if Jim does not do homework, then Jim will not pass. And then you could write the contrapositive of this if you want as well. So not this implies not this would say that Jim will not pass. So the opposite of that is Jim will pass. So if Jim passes, then Jim did homework. Number 6, consider the following argument. Is the conclusion valid? Explain why or why not. If compilation of a computer program produces error messages, then the program is not correct. Compilation of this program does not produce error messages, therefore this program is correct. So here's our first premise. Okay. If the compilation produces error messages, then the program is not correct. So this says the compilation of a computer program produces error messages. We will call that P. And the program is not correct. We'll call that Q. So the next statement here is not P, right? And the conclusion is not Q. So if we take the first supposition to be true, that P implies Q, and we know not P is true, you cannot conclude not Q is true. That is the inverse of P implies Q, and this is called the inverse error. Right? Assuming not P does not let you conclude not Q. And you could make a truth table if you want to show that this argument is invalid. So assuming that this is true and this is true does not tell you that the conclusion has to be true.